Ogg is a free, open container format maintained by the xif.org Foundation. The creators of the Ogg format state that it is unrestricted by software patents and is designed to provide for efficient streaming and manipulation of high-quality digital multimedia. Ogg is derived from ogging, jargon from the computer game Netrek. 3.3 Ogging. This is the art of killing a carrier, or potential carrier, by a suicide run. The Ogg container format can multiplex a number of independent streams for audio, video, text, and metadata. In the Ogg multimedia framework, the URA provides a lossy video layer. The audio layer is most commonly provided by the music-oriented Vorbis format, but other codec options include the compression codec Opus, the lossless audio compression codec FLAC, and OGG-PCM. Before 2007, the Ogg file name extension was used for all files whose content used the Ogg container format. Since 2007, the xif.org Foundation recommends that Ogg only be used for Ogg Vorbis audio files. The xif.org Foundation decided to create a new set of file extensions and media types to describe different types of content, such as OGG for audio-only files, OGV for video with or without sound, and OGX for multiplexed Ogg. As of August 4, 2011, the current version of the xif.org Foundation's reference implementation is libogg 1.3.0. Another version, libogg 2, has been in development, but is awaiting a rewrite as of 2008. Both software libraries are free software, released under the new BSD license. Ogg reference implementation was separated from Vorbis on September 2, 2000. Because the format is free, and its reference implementation is not subject to restrictions associated with copyright, Ogg's various codecs have been incorporated into a number of different free and proprietary media players, both commercial and non-commercial, as well as portable media players and GPS receivers from different manufacturers. Naming: it is sometimes assumed that the name Ogg comes from the character of Nanny Ogg in Terry Pratchett's Discworld novels, but the Ogg developers say that is not true. Ogg is derived from ogging, jargon from the computer game Netrek, which came to mean doing something forcefully, possibly without consideration of the drain on future resources. At its inception, the Ogg project was thought to be somewhat ambitious given the power of the PC hardware of the time. Still, to quote the same reference, Vorbis, on the other hand, is named after the Terry Pratchett character from the book Small Gods. The Ogg Vorbis project started in 1993. It was originally named Squish, but that name was already trademarked, so the project underwent a name change. The new name, Ogg Squish, was used until 2001 when it was changed again to Ogg. Ogg has since come to refer to the container format, which is now part of the larger xif.org multimedia project. Today, Squish refers to a particular codec typically stored in the Ogg container. File format: the Ogg bitstream format, spearheaded by the xif.org Foundation, has been created as the framework of a larger initiative aimed at developing a set of components for the coding and decoding of multimedia content, which are available free of charge and freely re-implementable in software. The format consists of chunks of data, each called an Ogg page. Each page begins with the characters OGS to identify the file as Ogg format. A serial number and page number in the page header identifies each page as part of a series of pages making up a bitstream. Multiple bitstreams may be multiplexed in the file where pages from each bitstream are ordered by the seek time of the contained data. Bitstreams may also be appended to existing files, a process known as chaining, to cause the bitstreams to be decoded in sequence. A BSD-licensed library, called libvorbis, is available to encode and decode data from Vorbis streams. Independent Ogg implementations are used in several projects such as RealPlayer and a set of direct show filters. Page structure. The following is the field layout of an Ogg page header. Capture pattern Euro 32 bits. The capture pattern or sync code is a magic number used to ensure synchronization when parsing Ogg files. Every page starts with the 4 ASCII character sequence, OGS. This assists in resynchronizing a parser in cases where data has been lost or is corrupted, and is a sanity check before commencing parsing the page structure. Version Euro 8 bits. This field indicates the version of the OGG bitstream format, to allow for future expansion. It is currently mandated to be 0. Header type Euro 8 bits. This is an 8-bit field of flags, which indicates the type of page that follows. Granule position Euro 64 bits. A granule position is the time marker in OGG files. It is an abstract value, whose meaning is determined by the codec. It may, for example, be a count of the number of samples, the number of frames, or a more complex scheme. Bitstream serial number Euro 32 bits. This field is a serial number that identifies a page as belonging to a particular logical bitstream. Each logical bitstream in a file has a unique value, and this field allows implementations to deliver the pages to the appropriate decoder. In a typical Vorbis and Thera file, one stream is the audio, and the other is the video. Page sequence number Euro 32 bits. This field is a monotonically increasing field for each logical bitstream. The first page is 0, the second one, etc. This allows implementations to detect when data has been lost. Checksum Euro 32 bits. This field provides a 32 Costa Rican colons checksum of the data in the entire page. This allows verification that the data has not been corrupted since it was created. Pages that fail the checksum should be discarded. The checksum is generated using a polynomial value of 0x04C11db7. Page segments Euro 8 bits. This field indicates the number of segments that exist in this page. It also indicates how many bytes are in the segment table that follows this field. There can be a maximum of 255 segments in any one page. Segment table. The segment table is a vector of 8-bit values, each indicating the length of the corresponding segment within the page body. The number of segments is determined from the preceding page segments field. Each segment is between 0 and 255 bytes in length. The segments provide a way to group segments into packets, which are meaningful units of data for the decoder. When the segment's length is indicated to be 255, this indicates that the following segment is to be concatenated to this one and is part of the same packet. When the segment's length is 0 Euro 254, this indicates that this segment is the final segment in this packet. Where a packet's length is a multiple of 255, the final segment is length 0. Where the final packet continues on the next page, the final segment value is 255. And the continuation flag is set on the following page to indicate that the start of the new page is a continuation of last page. Metadata. Currently, there is no official standard for including metadata in OGG containers. Implementation is still a long way off as of Q3, 2007. The Kshift.org Foundation are currently welcoming suggestions and feedback. Suggested metadata implementation methods include the following: Dublin Corona DF, XML encoding, Music Brian's XML metadata. OGG skeleton is emerging as the way to approach machinable metadata. Metadata must currently be included in the codec. There is fairly good software support for Vorbis metadata often referred to as comments. But software support for Thera and FLAC comments in OGG containers is very limited. History. The OGG project began with a simple audio compression package as part of a larger project in 1993. The software was originally named Squish, but due to an existing trademark it was renamed to OGG Squish. This name was later used for the whole OGG project. In 1997, the Xerophorus OGG Squish was described as an attempt both to create a flexible compressed audio format for modern audio applications as well as to provide the first audio format that is common on any and every modern computer platform. The OGG Squish was in 2000 referred to as a group of several related multimedia and signal processing projects. In 2000, two projects were in active development for planned release: OGG Vorbis format and libvorbis, the reference implementation of Vorbis. Research also included work on future video and lossless audio coding. In 2001, OGG Squish was renamed to OGG and it was described as the umbrella for a group of several related multimedia and signal processing projects. OGG has come to stand for the file format, as part of the larger Shift.org multimedia project. Squish became just the name of one of the OGG codecs. In 2009, OGG is described as a multimedia container format, and the native file and stream format for the Shift.org multimedia codecs. OGG reference implementation was separated from VORBs on September 2, 2000. In May 2003, 2 Internet RFCs were published relating to the format. The OGG bitstream was defined in RFC 3533 and its Internet content type in RFC 3534. In September 2008, RFC 3534 was obsoleted by RFC 5334, which added content types video OGG, audio OGG and file name extensions OGX, OGV, OGA, SPX, OGM. In 2002, the lack of formal video support in OGG resulted in the creation of the OGM file format, a hack on OGG that allowed embedding a video from the Microsoft DirectShow framework into an OGG-based wrapper. OGM was initially supported only by closed-source Windows-only tools, but the codebase was subsequently opened. Later, video support were formally specified for OGG but in a manner incompatible with OGM. Independently, the Matroska container format reached maturity and provided another alternative for people interested in combining VORBs audio and arbitrary video codecs. As a result, OGM is no longer supported or developed and is formally discouraged by Shift.org. Today, video in OGG is found with the OGV file extension, which is formally specified and officially supported. 2006. Although OGG hadn't reached anywhere near the ubiquity of the MPEG standards, as of 2006, it was commonly used to encode free content and had started to be supported by a significant minority of digital audio players. Also supporting the OGG format were many popular video game engines, including Doom 3, Unreal Tournament 2004, Halo, Combat Evolved, Jets and Guns, Mafia, The City of Lost Heaven, Myst 4, Revelation, Stepmania, Serious Sam, The Second Encounter, Lineage 2, Vendetta Online, Battlefield 2, and the Grand Theft Auto engines. The more popular VORBs codec had built-in support on many software players, and extensions were available for nearly all the rest. 2007, on May 16, 2007, the Free Software Foundation started a campaign to increase the use of VORBs as an ethically, legally and technically superior audio alternative to the proprietary MP3 format. People were also encouraged to support the campaign by adding a web button to their website or blog. For those who don't want to download and use FSF's suggested OGG player, the Shift.org Foundation had an official codec for QuickTime-based applications in Windows and Mac OS X, such as iTunes players and iMovie applications. And Windows users could install a Windows Media Player OGG codec. 2009, by June 30, 2009, the OGG container, through the use of the Theora and VORBs, was the only container format included in Firefox 3.5 web browser's implementation of the HTML5, video and audio elements. This was in accordance with the original recommendation outlined in, but later removed from, the HTML5 draft specification. 2010, on March 3, 2010, a technical analysis by an FFmpeg developer was critical about the general-purpose abilities of OGG as a multimedia container format. In a lengthy response, the creator of OGG refuted these claims. By December 2010, browsers supporting OGG had surpassed browsers supporting both MP4 and WebM. OGG codecs, OGG is only a container format. The actual audio or video encoded by a codec is stored inside an OGG container. OGG containers may contain streams encoded with multiple codecs. For example, a video file with sound contains data encoded by both an audio codec and a video codec. Being a container format, OGG can embed audio and video in various formats, but OGG was intended to be, and usually is, used with the following Shift.org free codecs: audio, lossy, speaks, handles voice data at low bit rates, VORBs, handles general audio data at mid to high level variable bit rates, Opus, handles voice, music and generic audio at low and high variable bit rates. Lossless, FLAC handles archival and high-fidelity audio data. Uncompressed, OGG-PCM, handles uncompressed PCM audio. It is broadly comparable to WAV. Video, lossy, Theora, based upon On2's VP3, it is targeted at competing with MPEG-4 video, Real Video, or Windows Media Video. Tarkin, an experimental and now obsolete video codec developed in 2000, 2001 and 2002 utilizing discrete wavelet transforms in the three dimensions of width, height, and time. It has been put on hold after Theora became the main focus for video encoding. derived, a free and open video format developed by the BBC. Uses wavelet encoding. Lossless, derived, a part of the specification of derived covers lossless compression. Uncompressed, OGG-UVS, a draft codec for storing uncompressed video. Text, RIT, a text codec designed to embed subtitles or captions. Continuous media markup language, a text application codec for timed metadata, captioning, and formatting. Anodex, a free and open-source set of standards developed by CSIRO to annotate and index networked media. Oggate, an overlay codec, originally designed for karaoke and text, that can be multiplexed in OGG. See also, audio data compression, comparison of audio coding formats, comparison of container formats, commons, file types, use of OGG formats in HTML5, Wikicommons Theora video conversion help page, Wikipedia, media help installing audio and video software, references. External links, the kshift.org Foundation official webpage OGG, RFC 3533 the OGG encapsulation format version 0, RFC 5334 OGG media types, RFC 3534 the application OGG media type, obsoleted by RFC 5334, using Creative Commons metadata in OGG containers, OGG etymology from the jargon file, kshift.org's official OGG QuickTime components for iTunes and iMovie, Windows Media Player codecs for Vorbis, Speaks, Theora and FLAC, FFmpeg2 Theora OGG Theora encoder, command line application for Linux and Win32, online tool to convert OGG files, no downloads, Miro video converter, free online OGG converter.